Welcome to the Real Python Podcast. This is episode 115. Have you heard about PyScript? The brand new framework has the community excited about building interactive Python applications that run entirely within the user's browser. Would you like to dig into the details beyond the Hello World examples? This week on the show, Christopher Trudeau is here, bringing another batch of PyCoders Weekly articles and projects. We talk about a real Python tutorial from Bartosz Zaczyński about PyScript. The article provides an initial look at the framework and then takes the reader deep into the intricacies. We also share additional resources to help familiarize you with the project. Christopher talks about another real Python article about how to approach managing errors in Python. The tutorial, LBYL versus EAFP, Preventing or Handling Errors in Python, is from frequent contributor Leodanis Pozo Ramos. We cover several other articles and projects from the Python community, including discussing the PSF's Python Developers Survey 2021 results, Django static files and templates, how to profile Python code, a launcher for penetration testing, and a project for confirming Python versions through syntax errors. This episode is brought to you by CData software, the easiest way to connect Python with data. SQL access to more than 250 cloud applications and data sources. All right, let's get started. The Real Python Podcast is a weekly conversation about using Python in the real world. My name is Christopher Bailey, your host. Each week, we feature interviews with experts in the community and discussions about the topics, articles, and courses found at realpython.com. After the podcast, join us and learn real-world Python skills with a community of experts at realpython.com. Hey, Christopher, welcome back.
Glad to be here.
All right, so we're diving into a couple kind of big real Python articles, and then we got a couple other tools and resources to kind of dig into. We're going to bypass the news a little bit, though our discussion is a little bit newsworthy. So let's get rolling. What's your first one?
Sure. My first article is, say it with me, Leodanis Pozo Ramos. He's going to think I'm stalking him.
Yep.
It's called LBYL versus EAFP, Preventing or Handling Errors in Python. So let's start with the bulky acronyms. LBYL is Look Before You Leap, and EAFP is Easier to Ask Forgiveness Than Permission. So what's this mean? The heart of it is how you deal with error conditions in your code. So Leodanis says, historically, preventing errors before they happen is the most common strategy. I disagree with him here. Doing nothing and having your program crash is probably the most common, but I get his point.
High five.
So the first one, look before you leap style, is the idea of checking whether something's going to fail before you do it. So a simple example of this would be conditional that looks to see if a key is in a dictionary before you try to access it.
Okay.
So you go, if X is in dict kind of thing. So the else clause on that condition would be dealing with the missing key and giving the user an error or whatever kind of behavior you want in the error condition. By contrast, easier to ask forgiveness than permission style, it would be directly accessing the desired key. And of course, if you don't want to crash, you have to deal with the key exception. So in Python, this is done with a try except block. And inside of the try except block, you access the key. And inside of the except part, you catch a key error and do the same kind of error handling you would have done in the else condition that I mentioned in the other style. So these are really just sort of two different ways of doing it. Most modern programming languages support both mechanisms. Some of the older ones don't have exceptions. So this is sort of one of those contrasts that happen in language design. So you've got these two styles in Python. How do you pick which one? As with a lot of things you expect, there's pros and cons to both. And of course, flame wars have erupted out of less. The article even goes so far as to quote Guido, the original creator of Python, saying that neither one is considered preferred in Python. So pick what makes sense for your situation. The advantage of using try except is you can usually get away with fewer checks. You can wrap a longer block of code inside of the exception catch, and you're not having to constantly go if then kind of thing as you're going along. The other advantage, which I kind of like, is it tends to be a bit easier to read.
Okay.
Having every line of code wrapped in a conditional means visually you're parsing the conditional to see what the code is doing, whereas in a try block you just see the code. So I find it tends to be a little more readable. So those are two good reasons to use the try except. Why might you want to use preventative instead? Well, there's performance implications. This one varies from version to version of Python. So in fact, in the coming release of Python 3.11, a bunch of work has been done to reduce the cost of exceptions. But the more exception checking you do, the more overhead the code has. So for a small number of possible errors, try except might win out. But if you've got a big variety of exceptions that can be thrown, your code may take a performance hit. A profiler can help you figure out if you're paying this cost. And that's some foreshadowing, which we'll hand off to you for later.
Yay!
So the article's full of snippets for each of these cases, showing you why you might prefer one or the other, and then digs even deeper in with a series of examples that's quite concrete. And in case you want to take another crack at this, around the same time this article came out, Luke Plant, who we've linked to before, wrote one called Raising Exceptions or Return Error Objects, which then became a topic on Hacker News. So we'll include links to all of this, but there's sort of 3 different ways to go at the same subject material if you're interested in this.
Yeah, I wonder if some of this came up, especially the stuff kind of around 3.11 and these sort of faster ways of dealing with exceptions and sort of the overhead cost of them. That's definitely, they've brought a couple new people into the team, and there are people that are directly working on some of those things. And there's a bunch of conversation within the Real Python team about it because it's very interesting, like looking at ways to kind of speed stuff up.
Yeah, I haven't dug into this part explicitly yet, but there's this banner headline called Zero Cost Exceptions in 3.11.
Yeah.
And it's a case that it's not zero cost all the time. There's sometimes when it costs zero, and there's sometimes it costs more than that. And I haven't read anything yet to dig into how the difference is. But even if you're removing this cost, sometimes that can help the speed in a lot of people's code.
Yeah, that's cool. And then I think it's really funny that it just kind of is a theme for Python. And I'm having this conversation with Bruce Eckel in a couple weeks here, where we talked about how Python has so many different ways that you can approach it, let alone the, foreshadowing something we're going to talk about later of like the survey of like how people use Python, but literally like how you develop inside of Python, you can kind of choose the path you want. And I'm just really finding that to be such a common theme. So here's yet another one. Like you were saying that some languages kind of steer you in a direction one way or another. Do you have a concrete example of that too? Like where one of them typically just is all about exceptions versus the other way?
It tends to be the other way around. So some of the older languages like C didn't have exception management in them, right? So try except blocks were added in C++.
Okay.
So you just can't use exception mechanisms. There are things you can do that approximate it, but then you're basically inventing exception handling inside of your code.
Yay! Roll your own. Cool. Yeah, so that's great. And that leads me into nicely talking about how to profile Python code is the title of this article. And this one is on a blog called Code Solid, and the author is John Lockwood. This is a really nice overview to get you into thinking about profiling, but also not just profiling. He also kind of has this section where he's talking about the differences between benchmarking and profiling. The performance of Python. Does that ever come up on the show? We can always broach a new topic if in case people are interested. Yeah. And this is kind of a interesting thing in that sense that often I feel like the development cost is always the thing that is the big win with Python. Like how long how quickly you could kind of develop things is really nice. Do you need to profile our stuff? That gets into an interesting argument there. And then when to profile is a whole other one. I thought it was really kind of interesting. Like primarily the bulk of the article is about sort of a short survey of 7 different profiling tools, how you can kind of use them and check out, how your code is performing, either on kind of an overall level or at like a line by line or function by function kind of level. And before diving into those tools, he covers some of these profiling terms and key concepts to get you a comparison of them. The first concept is profiling is a late stage activity. And then I put in parentheses based on what he described, or is it? Question mark. He feels that profiling helps find bottlenecks. And this is a quote: "The famous dictum that premature optimization is the root of all evil did not mean that you shouldn't optimize at all, but rather that you shouldn't optimize the wrong things, which you're likely to do if you don't know where the bottlenecks are." And so he's arguing somewhat in this that it's good to check for the bottlenecks sometimes as you go. I guess that really depends on how you develop. I would always think of like you would want to stand everything up and kind of go from there. But I guess it kind of depends.
I think he's just getting at, like, say if you're doing test-driven development or something, you don't have to wait until everything's done. If I've got my function done and I want to check it, then, profile the function, right? That kind of makes sense.
Right.
The other aspect of this, which is kind of the big picture aspect, is something called Amdahl's law. And essentially this talks about diminishing returns. And so, if you've got a part of your calculation which is taking up 80% of the time and you improve that, you're going to get a big boost.
Yeah.
But if you've got part of your calculation that's only taking 5% of the time, even if it's the slowest part, fixing it may not make any difference. So you kind of have to balance this act between how do I optimize my piece versus how do I think of the whole.
Yeah. Okay. What I think is interesting in that process is there's a lot of references to doing things in Jupyter notebooks. The idea there very often is that you kind of are really breaking apart your code into these cells and kind of running the cells and then being able to kind of gauge the performance of those cells as you go, I think is really kind of handy. And then there's lots of tips and tricks there. And then also just snippets and, how to apply these techniques in there. One of the other terms and kind of key concepts is the difference of sort of profiling versus benchmarking. And benchmarking is more like a macro view of performance, like overall timing of things and how the whole thing kind of runs, and you can kind of see the overall sort of speed. And then he kind of gets into this wall clock versus CPU time thing. But profiling is much more micro. It gets really into showing you individual portions of your code and how they're performing and maybe how much memory they're using.
And the wall clock versus CPU time gets into whether or not throwing parallelism will fix your problem.
Absolutely, yeah. And then he has another little section on deterministic profiling versus statistical profiling. I'll let you kind of dive into those, but I like that he did that he kind of covers some of these terms and key concepts that can kind of really dive into much deeper areas if you want to get into them. And then he shows a typical scenario, provides a few examples, and again, what I really like about it is he's showing using the commands and some of the common flags that you would use to not only run it in the console, but then again, shows you how you could use them in a Jupyter notebook. In his case, he starts with profile and cprofile, but I want to mention timeit first because it's kind of the one that I have seen the most. And again, it is more in that benchmarking side. It measures the average execution time. You can measure an individual function, or you can use it to measure a whole program. Then profile and cprofile, those modules, this is, if you were to read the Python docs, they're the recommended tool inside of it. He mentions a couple other additional ones here. Line profiler, which needs to be pip installed, which focuses on function calls over, like, say, cprofile. Memory underscore profiler is more about visualizing the allocation of memory and the deallocation of it, kind of, again, watching your program do that sort of stuff. Again, he provides what in Jupyter parlance, they call them magic methods, which is like this percent sign you may have seen in front of things like time or timeit. So he then also shows ones like P run and LP run and some of these other ones that are more individually for some of these other profilers. Then he gets into two other tools that are a little more advanced that are kind of, again, more like an overall picture kind of thing. One is called Scalene, I guess is how to pronounce it, which is SCALENE, which profiles not only like the memory use that we've talked about already, but also CPU and GPU, the graphic processor unit use. And it provides like a web-based graphical user interface, GUI kind of thing, that shows percentage of time in the various parts of the code. And then the one he ends with is called Yappy, which I can think is like a small dog at that point. It provides support for understanding CPU versus clock time. And that's really good for this sort of idea of profiling multi-threaded code, like you mentioned, or heavily using async IO and stuff like that, and kind of seeing the performance there. So it's a really nice overview of all these different sort of tools, I guess 7 different tools. Some are built in, some you may have seen before. And I thought it was a nice survey. And if you're interested in getting deeper into the profiling area and kind of seeing the performance of stuff, lots of opinions there of like when and where to use it. And then lots of support for not just running things command line, but also, potentially running them in your notebooks as you work through things in there.
Do you use any of the tools you mentioned?
I've used Timeit quite a bit. I have started to look at Profile and cProfile, but a lot of my programs, I don't. It's kind of like the testing thing. Like I'm standing it up and making sure it's running and so forth. I'm getting a little better about test-driven development, which actually kind of leads into your next thing. The bigger projects I've done have lately been more like Django types of projects. And I was actually following some of that author's books, Will Vincent's books, and he's very much heavily into having you build the tests as you go. And so that's been part of it. But
right.
I haven't really had this sort of hit. The place where I saw performance bottlenecks was in data science and watching people do things where they would just like sort of shrug and go, well, I guess this will be done in a few hours. And I'm like,
right.
Is this the best way to do it, is to make it be a break in your day kind of thing while it runs the programming? Because I would think sometimes there'd be some efficiencies there you could really look at. But very often people are like, well, I'll just do other things while that's going, sort of their own version of multiprocessing.
Yeah.
So
yeah. I'm not, I find Timeit confusing.
Okay.
Every time I go, I don't use it frequently. And every time I go to use it, I always have to look up the documentation, particularly trying to like the context stack and what variables are available and not available.
Yeah. You can really have it run forever if you're not careful.
Yeah. I'm a big fan of perf counter,
okay,
which is inside the time library, and it basically just spits out a counter. So you put one before, you put one after, and subtract the two. It's really simple.
Yeah.
It doesn't give you where it's spending the time or whatever, but if you put a few of those inside or just looking at your logs. The other one, which isn't mentioned in the article because it's Django specific, is the Django debug toolbar.
Okay.
It's got a whole bunch of timing pieces inside of it, including drill downs on how long each of your SQL queries take. So if you're in the Django space and your page is running slow, it's probably the database you're doing on the back end, more likely than anything else.
Yeah.
And so it'll tell you, oh, you're doing 15 queries on this page, and these 2 are the slow ones. So, and I'm sure there's other tools similar to that out there for other web frameworks. So there's lots and lots of options out there.
Yeah, I think in a common thing when we're talking about decorators is to make like sort of a bit of a performance or a timer, a timing tool. And I think perf counter is a popular thing there. So you could say, okay, I want to run this function through that and see, how it's performing, and just by adding the decorator.
Yep. Spit out the before and after. It's a classic decorator, intro to decorators example.
Absolutely.
Yeah. I should keep it in mind because I'm writing a course where I have to do some of that. So maybe that's what I'll do. Time it.
There you go. Nice. CData software. Connect, integrate, and automate your data from Python or any other application or tool. At CData, we simplify connectivity between all of the applications and data sources that power business, making it easier to unlock the value of data. Our SQL-based connectors streamline data access, making it easy to access real-time data from on-premise or cloud databases, SaaS, APIs, NoSQL, and big data. Check out cdata.com to learn more. So that leads us into your article from Will.
Yes. So Will's written something called Django Static Files and Templates. before getting into the article, in case you're not a Django person, I need to give you a little bit of background. Django is one of the more popular coding libraries for building websites in Python, and it divides the world into three sort of concepts for stuff it serves. The first one is a view, the second is static files, and the third is media files. And the article is really on the first two. A view is some code, either a function or a class. I prefer the functions, but that's editorial, that's run when someone hits a URL. So if, let's say we're writing a homepage, I define a route that maps / to a function called homepage. And when you hit / with your browser, Django calls the homepage function. And that function then has to return an HTTP response object that contains the content that the web browser displays. And of course, that content's usually a web page. And web pages are kind of meta, right? They have content as well as pointers to other kinds of content inside of them. So on that same home page, I might have the website's name, a logo, and maybe say if I'm logged in, an avatar image, right?
Yeah.
So the view is responsible for the page itself, but the logo is what Django calls a static file. So static files are content that typically doesn't need to be rendered and just are sent down. And this includes things like your images, your style sheets, your JavaScript, all that other stuff that got added to the web after Sir Berners-Lee there defined it at the get-go.
Okay.
And then the third category is media files are kind of like static files in that they don't need to be rendered, but they're different in the fact that they're user provided. So they were uploaded into the system somehow. So now that's the background. Now the article concentrates on static files and how you incorporate them into your site and the differences between the dev environment and, say, a production environment. I'm going to do this backwards. So we'll start with production. Because these files don't need anything done to them by Django, it's actually inefficient to have them served by Django. The recommended production setup is to have a web server fronting Django, so Apache or Nginx or something like that. And the web server, if like say Apache, routes for certain URLs to Django and handles the others itself. So a common way is to say have a /static, which the web server serves all the static content from. Again, your images, your CSS, and your JavaScript. So that's all well and good, but now you've got to figure out how to get that CSS and image files out of your project directory into the right place on the production server. So to help with that, Django has a command called collect static. And if you've got your settings configured correctly, and the article tells you what settings you need and how to get all that, this command copies all of your static files into the web server's directory so that the files can be served. This is so common that if you're hosting a project at Heroku, for example, it calls this command automatically. This is a typical way of doing things.
Okay.
So the Django dev server knows how to serve static files. So you don't have to do all this mucking around if you're just playing around locally, and it just feeds them out to your project. But it only does this if you're in debug mode, which is good because you only want to be using the dev server if you're in debug mode and you're testing locally. So now you've got the complexity of I've got a web page and the URL might be different if I'm in dev or if I'm in production. So how do I deal with that? So Django deals with this through what's called a template tag. So Django supports several different templating languages. And they basically allow you to do code reuse and inheritance on HTML the way you would in, say, object-oriented Python. And within Django's template language, there's a thing called a tag, and that's something that gets replaced by some code. And the one in question here is something, the tag is called static. And that static tag gets replaced with the proper URL in the proper situation. And it takes a parameter. So let's say we were feeding style.css, I'd say static and then give it style.css. And then if I'm in dev, it gets replaced with the dev URL. And if I'm in production, it gets replaced with the production URL. And Django takes care of all this when it renders the template. So Will's article details exactly what settings you need for all of these things. It even briefly touches on how you could move your static files into, say, like a CDN instead of a web server.
Okay.
With the help of a library called White Noise. So if you're new to the Django space or you're curious as to how these pieces fit together, there's a lot of information here on how all those parts go. It's one of those things that I find new Django developers, sometimes it takes a little bit to wrap their head around. And
I laugh because I'm that guy.
You end up seeing like a lot of hard-coded URLs and things that you don't want. And so this is kind of the right way to do things.
I'm glad he's done this because It is so hand wavy very often when people just say, just use white noise or just use collect static. And it's like, okay, but what? What is it doing? Like just even your little description there, like kind of like cleared up a whole bunch of it. Oh, that's why it's doing that. And it's like, because you sit there and you develop it on your own computer, but hosting it and serving it is like this whole other thing, and the behavior of it is going to be so different from what's happening on your own machine. And it's like this weird switch in mentality. And so I appreciate that. And his blog is really great for that stuff.
Well, and there's like 4 or 5 settings that impact how the static library works. And if you don't get them right, it's not going to work, right? So, and although the Django documentation is good, if you're new to the concept of hosting somewhere besides just running a server locally, that there's a lot to chew here, and articles like this help.
Yeah, he has a couple books. I think I bought all 3 of them over the years. He has a Django for Beginners book, a Django for APIs book, and then a Django for Professionals book. And what I have appreciated across the board is, I bought them several years ago, right as before I even was in real Python, and was very interested in this platform. And he's updated them to the new versions and provided the new versions. They'll have a little star on them, and now say Django 3.1 or Django 4.0 or whatever, which is just so impressive. And my hat's off to him for doing that. So if you're interested, it's William S. Vincent, and he's got a good set of these books, and he really stands behind him. He has a podcast also. It's called Django Chat. Carlton Gibson, who's one of the core developers, has it with him. And I think Will is now also. But if you want to do deep dives on Django, it's kind of a nice resource. Well, that brings me to talking about web stuff a little bit. Is a new article by Bartosz Zaczyński, and it is about PyScript, which we've kind of mentioned briefly here. There's a huge buzz about this right now. The title for this particular Real Python article is A First Look at PyScript, Python in the Web Browser. If you haven't heard of it, PyScript is a brand new, tool, platform. I don't know what to call it exactly.
Magic
that was revealed during Peter Wang's keynote at PyCon US 2022. I saw the first half of it, and so I kind of missed the reveal, but got to learn a lot about it while I was there. That talk is up now. It's on YouTube. You can check it out. And I do suggest you do that, maybe even before you dive into this sort of deep dive. Peter Wang, if you're not familiar with him, he's the CEO and co-founder of Anaconda. I asked him, and he sounded interested in coming on, and so we're still working that out. So potentially I'll have Peter as a guest sometime soon. And then Russell Keith McGee is somebody I've had on the show a long time ago who works on Beware, and I found out that Anaconda is helping support him. And part of it is that he is working on Toga elements that will work with PyScript, which I think is really great. And so I'm thinking about getting Russell back on here to talk a little bit about updates to some of that. So like I said, you really should watch this PyCon keynote. It'll give you a really good idea behind what's going on with the project and some of the goals they have with it, and also kind of where it is right now. The primary goal is to be able to make things that run in your browser. Now, we talked about Pyodide a few weeks back. This is using Pyodide and kind of building on top of it. And what I think is really interesting that comes across in the talk is the idea of bringing this serverless idea to like a completely new meaning or definition in the sort of development world. Serverless means that they're not your servers in most cases. This is saying no server. Like, let me just give you an HTML document that maybe I could put on a thumb drive or send in a message or something like that. And that HTML text file is everything you need to open up a Python script and have it run in, or an application or a dashboard or what have you, and have it just immediately run on your computer. And it could be any platform of a computer, because it's downloading this environment of this JavaScript library of a PyScript ready to go in it, which is really kind of amazing. So first off, big disclaimer, 2 big things about PyScript. It is experimental at this stage. It is literally only in alpha. They're pushing changes all the time. The idea kind of started in February, and then by the end of April, they're like, here, 2 months in, let's just show it off. And I think the idea is they're so excited about it. They would like to get more people involved and do stuff with it. And in that case, it means kind of get you involved in playing with it, if you will, a little bit. So how to get started with it? Well, the article is really great. Bartosz has, in his first few pages there, it's like, okay, here's kind of a section on getting started and wrapping your head around PyScript, and then writing a hello world, which is really fairly easy. The one odd thing for a lot of Python developers is that you do need to kind of understand like the first hour of HTML, the idea of like kind of the basic tags that you would see in an HTML. So if you haven't ever done anything with HTML, this can show you some of that, but there are other additional resources to kind of get you going. You do kind of need to know a little bit about that. It fetches the Python runtime from the internet and, basically runs it. And it's the simplest way for it to work. There's a button on the PyScript site that has a bit of a joke to it. It says, install PyScript. And when you click it, it says, just kidding, you don't need to install it. Because it, again, can just pull down this JavaScript library and just be ready to go. But as a dev diving really deep into this alpha, you can download the entirety of PyScript stuff for offline development. So like if you didn't want to have it download as a JavaScript library from a CDN, you can do that. This article goes really deep into that, and there's a lot to that. Just to understand, you're downloading, not only the PyScript, but the CSS for it and all these other kind of resources as actual files. And then you can then download a specific pyodide release that's working with it. And then with that, you need to verify it, and kind of gets really more into that whole tooling thing and dealing with that sort of stuff. Quick thing, HTML and JavaScript and CSS do not care about white space. And what's one of the key things you've probably learned about Python is that it's really dependent on that. And so there's a little bit of weird stuff with that. Like there are tools for HTML and JavaScript development that do minimization, that sort of suck away all the the white space, so it's not there at all. That typically will break certain Python stuff. So there's some mention about that and talking about it. The second project goes a little further, kind of going a little bit into the thing that I showed about pyodide a couple weeks back, where I was showing you how to kind of build a REPL. This is an even shorter version of that, which is really nice, emulating a REPL and kind of a Jupyter notebook in one. The article gets into some really nice things they've added in I see this is the area that PyScript's going to go much further with. The actual visual components like PyTitle, PyBox, PyButton, PyInputBox. And that stuff I think is going to be really great, because the other way to do that currently is to get really into JavaScript and understanding HTML elements and the DOM, the document object model, and understanding kind of how to deal with those kinds of things. And so anyway, you can get really deep into that. And Bartosz has gone really far into kind of explaining some of that stuff and showing the connection with it. It gets into like cookie management and actually working with APIs in this environment. Inherently, JavaScript is asynchronous. Python is not. So there's some interesting things you have to think about with that kind of dealing with that. And he goes into that, which is really nice. To me, I think someone looking at this as they get, 45 to 50% the way into this article might be thinking, but I thought that we were making things simpler. So the alpha status, I think, kind of will make you kind of do a little bit of that. And also the idea of doing this like really deep dive. I don't know if you need to go this far. And what I think, if you're feeling that way going through this article and you're like, oh my God, this is getting a little too crazy, you might be able to pull out of it a little bit and say, well, let's go look at the examples that Peter talked about in his talk, because they actually, I think, can give you a better idea of like how I think they see people using it eventually, is kind of doing this much more higher level thing where you can just have, it import the JavaScript, import potentially these other libraries that are, built into it. That does take a little bit of time. My internet connection is pretty fast, so I haven't really seen it be a big problem as far as loading pages. I have other web pages that take longer. They're showing really great examples of things like doing bokeh and doing other pretty common things that you may want to do, be it data science or otherwise. There's a good whole repository with all these, examples that you can kind of see up and running. I would almost steer you there.
And with this being packaged inside HTML, it may help solve one of the problems that we have, which is needing Python installed, right? Like,
yeah,
I can't solve a problem for my mom and send it to her because I'm not going to get her to install Python on her machine to be able to do something. Whereas I could email her an HTML script and say, click on that,
check it out,
fill in the form, and it'll do what you need, right?
Yeah.
So that I think there's an inherent value just in a packaging standpoint for certain kinds of problems.
Yeah, absolutely. Yeah, the idea of delivering things like I that was such a common thing. Like if I had like some executive that I was working with that isn't a programmer and I don't want to have to install Python on their system and so forth, the idea that I can send them an HTML file, and I don't have like the solution before was like, oh, I'm going to serve something, have it up on a intranet or something like that, and have the person go there. Even that sometimes is complicated. Typically, somebody could open up an HTML file. Typically, they're doing a lot of really cool stuff in the background. They're taking very powerful JavaScript libraries and making them work in Python directly, which is really interesting. There's a library called D3 that's really powerful for doing visualizations and animations, and I'm very excited looking at those examples. But it's definitely a watch this space kind of thing for me. I'm very excited by what's happening with it. It's not ready for production, please. But if you want to play with it, and you are more on the developer side and more on the deep dive side, Bartosz goes even further. He gets into like showing an example of this thing called the sensor API, where you could have it interact with like a phone's gravity, kind of accelerometer sensor in it. It works with an Android-based phone. I did not work on my iPhone. I was able to get it to run on it, but I wasn't able to get it to check out the sensor. So a little bit different stuff there. He gets into even publishing your PyScript application and maybe putting it up on a GitHub page, and then also contributing. It's a really, I'm just kudos to him, to Bartosz, for in a really short few weeks since PyCon, putting this all together and actually reaching out to some of the core developers of this project. Kind of a nice sort of example of the community's reaction to it. It's done really, really well. A lot of people are very excited about this article, and Peter Wang himself mentioned it on Twitter. So that's really nice. So I'm like I said, this is a great, more than a first look, in my opinion. It's a bit of a deep dive into the things that you can do with it. If you're looking for something a little more shallow, definitely watch the PyCon talk and kind of go play with it and look at some of the examples you can kind of see on there. In almost all cases, they're CDN hosted JavaScript library stuff, which is great, that you can kind of go in and kind of play with examples using matplotlib or bokeh or a bunch of really cool examples. I was very impressed with it. So I think this is kind of a neat tool, and I think it will be handy as far as like delivering things. And there's no real compilation and packaging and so forth kind of steps. This idea that generally it's just an HTML file, very often a single page, which is pretty slick. This week, I want to shine a spotlight on another Real Python video course. It's titled Building a Django User Management System. The course is based on Real Python tutorial by previous guest Pavel Furtek. And the instructor for the course is Darren Jones. He takes you through how to work with Django user management and add it to your Django application. You'll create an application where users can register, log in, and reset or change passwords on their own. You'll edit the default Django templates responsible for user management. You'll learn how to send password reset emails to actual email addresses. And you'll dig into how to use an external service like GitHub OAuth to authenticate users. So many Django tutorials gloss over user management, but I think learning these fundamentals is crucial before releasing your project into the world. And like most of the video courses on Real Python, the course is broken into easily consumable sections and has code samples for the techniques shown. All of our courses include a transcript and closed captions. Check out the video course. You can find a link in the show notes, or you can find it using the enhanced search tool on realpython.com. that brings us into our discussion, and we decided to kind of, instead of putting this in the news, we decided to kind of put it in the discussion. And it's the Python Software Foundation does a developer survey, looking at Python developers. And this is the 2021 results. And I don't know if you want to take it off from here, and I'll just add my comments as we kind of go.
Sure. Yeah. So like you said, this comes out of the PSF in connection with JetBrains. Those are the folks who create PyCharm. Over 23,000 developers participated, including me, or at least I think I did. 2021 feels very long ago. I think I participated in a survey. And there's because it's a developer server, there's data available that you can play with. So the survey starts out with links that go back to all the surveys to 2017. And if you dig around, you can actually get the data that they use to visualize this as well. So if you want to go and play with it inside of your own mechanisms, you can do that.
Yeah.
There's a lot of questions and sort of categorization pieces that in here. The first one talks about general Python use, and it's really almost a red herring because it talks about the fact that 84% of people replied Python was their main language. Well, yeah, this is a survey for Python developers. I'd be surprised if the answer was 3%, right?
Yeah.
So that one's a little weird, but ignoring that, the question that goes along with it is, what other languages do you use? And JavaScript and HTML are the two most popular, used in conjunction with Python, when Python is the coder's primary language.
Yeah.
If they aren't, then, and I guess this isn't really sort of all that surprising, right? Because there's a lot of Django and Flask out there, and you really can't avoid it, is really what it comes down to.
Yeah.
But interestingly, so there are almost 3 times as many developers in the data science space who don't use a secondary language as to those who aren't in the data science space. So let's try that again. So if you're in data science, they almost all 3 times the number of data scientists use Python exclusively and nothing else.
Yeah.
And so if you're outside of data science, I suspect this is really being driven by the whole web development place, and you don't have a choice, right? If you're doing web development in Python, Django or Flask or whatever, of course, you got to marry it with some JavaScript and HTML.
Yeah.
And I'd love that to be fixed someday, but yeah, that's me dreaming. So 52% of respondents said they use Python for data analysis, but only 29% of respondents consider themselves a data scientist. So that kind of tells you that there's a lot of folks out there that are doing analysis in Python that are multi-jobbers, or it's not part of their full-time job, but they still have to do some aspect of it.
I think that's some of the Excel people that are, like kind of growing out of that and saying, maybe we should automate some of this or use Python for it.
I suspect, and to the point you were making earlier about, having to deliver something for your boss, go run analysis on these logs. I'm not a data scientist, but we got to go run analysis on these logs, right? And I think that's where some of this is coming from.
Yeah, totally. Cool.
There were a bunch of questions about tools and environments. 63% of respondents used Linux, 58% Windows, and 25% Mac OS. You could answer yes to more than one of these in case you were doing the math in your head there.
Yeah.
The interesting thing about the Mac I found, and of course I'm biased because I'm a Mac user, but the number is significantly higher than the general population, which tends to be less than 10%. So there's obviously a draw there from a developer perspective. We're overrepresentative in the population.
Yeah. I'm wondering about that, if like Docker is part of that Linux thing in some ways.
I don't know. The container questions were sort of separated out. I think this was more of the, like, where do you build and run rather than hosting.
Okay.
Because it was linked in with things like your IDE choice questions and that kind of stuff. So I suspect some of that's separate.
Yeah, and then I thought it was interesting the Windows usage has risen 10 percentage points.
Oh, I missed that.
I'm guessing maybe that's getting easier. I know that they've been working on
it. It's
yeah.
So with the with the Linux subsystem in there,
yep.
I used to dread having to work on a client where they made me use a Windows box, and now I'm just like, oh, okay, I will use your Windows box. I'll do it by opening a window that puts me in Linux, and then I'm happy. So. The other piece they were talking about environment-wise is, start a nice little flame war about your editor of choice.
Yay.
The modern version of VI versus Emacs is VS Code versus PyCharm.
Yep.
They were neck and neck. They were both just over a third each, or just under a third each, sorry. My personal choice, because I'm an old man, is Vim. It was a distant third with a rocking 7%. So that kind of tells you how quickly that long tail drops off.
Recent news on that, Atom, which was, I guess, GitHub's tool, just got end of life, I guess.
Yes.
Which makes sense. I mean, in the sense that Microsoft, already has the VS Code tool that kind of subsumed a lot of it. But I remember using it when I was getting into HTML and CSS before my Python, that Atom was a very commonly suggested thing. So.
Well, and I encourage listeners to try Vim. Once you do, you'll never leave. That's not necessarily because you'll like it. It'll just be because most people can't figure out how to get out of Vim. So,
right.
And it'll help our usage stats next time for the survey next year.
Well, it's still running.
I'd like to see a question on the background is, what's your primary ID? And the second question is, do you have a Vim session you can't exit running in the background somewhere? Because that'd be interesting to see the difference. The other one that I saw, and I don't know whether this was just an error or an Easter egg, but it amused me. Near the end, there's a chunk of placeholder text that I think didn't get replaced. One of the questions about how much coding experience you have in Python and years of coding professionally. And God, there's nothing like that question to make me feel like an old man. But the summary underneath said, however, if compared to the most common type of star in the universe, the red dwarf, the sun is quite a bit larger. And I'm not sure how that's relevant, but it amused me. So
Nice. There's some other interesting little pieces in there that kind of touch on stuff that we've talked about on the show. A question about the developer in residence, how people kind of feel like that's going, which is really kind of cool.
And we need to figure out how to make more people aware of him. Because
it's like 70, almost 3/4 of people, or I'd never had heard of that. So
yeah,
I need more podcast listeners. So then there's a lot about packaging, which is kind of interesting. Like, how would you package something? Where are your packages coming from? Like, are you in an organization, where that is, cloud platforms? So yeah, a lot of really great information. And so, I definitely suggest people to kind of dig in, just kind of see, where you sit inside of that. And then definitely, next time it comes along, I will do my best to try to make sure people are talking or, taking the survey. Let's try to get the stats up, and hopefully, there's got to be how many million Python users. So this is a kind of a bit of a small survey, not a bad amount, but still, I think there could be more representation in that. So,
well, the other thing I find can be helpful with these kinds of things is not that this is their intent, but I frequently find I'm like, oh, I don't know what that is. I'll go find out what that is, right? Like you get a list of, where do you install your packages from? And if you've never heard of Anaconda, you're like, oh, well, that's the fourth most popular. Maybe I should go check that out, right? So there's little things buried in there that can be helpful besides just how do I compare, and what is my environment like in comparison to other people's?
Yeah, actually, now I noticed that at the very tail of it too, there's a whole participate in future surveys, so you can add your email to it and make sure you get notified about it. So that would be good. Cool. And I guess that gets us into a couple projects.
For sure.
What's your project?
So I found this interesting little corner case in the world of talking about multiple versions of Python. It's called Python Syntax Errors, and it's by Jacob Wilk.
Okay.
So the premise here is it's a catalog of code which you can import. It's set up as a module that does nothing but cause syntax errors in some versions of Python. So, for example, the snippet for Python 3.0 uses the ellipsis. That's the ... which was introduced in Python 3, and it's equivalent to the pass statement. And ellipsis is only valid in 3.0. So if you want to guarantee your users are using 3, you can put ... at the top of your file. And if they're running Python 2, they'll get a syntax error. And if they're running Python 3, it'll work. So it's kind of an interesting concept. So There's a similar corner case. These are sometimes called no-op statements or no operation. These are things that don't do anything, but will trigger compile errors in certain situations. And his library goes all the way from 2.4 to 3.11, with the exception of 3.2 for some reason.
Huh.
And I'm not sure that I would recommend this over, say, using sys.version if you're actually trying to accomplish this exact idea.
Yeah.
But as an exercise in understanding the compiler and how Python's changed over time, and in some cases for me, it was like, is that even syntactically valid? What is that doing? So it was a bit of a sort of compiler Python education experience, which I thought was interesting.
Yeah, cool. Mine goes into what always seems to happen for me with these projects is it ends up being like this rabbit hole of research and discovery, and I just find all these additional things. I initially was interested in this as a lead off from my recent episode with James Plugger about security, and the tool that was on PyCoders was called Arsenal. Subtitled is Inventory Launcher for penetration testing. So the idea is there are going to be a set of tools that you typically are going to go through in penetration testing. And I think I asked James about this a little bit, this idea of like kind of like a flow chart or other kinds of things. And it actually provides this nice set of these mind maps or images that kind of show you the steps of penetration testing and two unfortunate little targets, Active Directory and Exchange. So definitely kind of see where the penetration testing comes up very often in sort of the corporate environments that are out there. And it is just that. It's a quick inventory and a reminder and launcher for pen test commands. It provides a set of not only which tools you would use, but the commands you would use in that. And that's where it led me into this whole rabbit hole, because it was inspired by a project called Navi, which is sort of an interactive cheat sheet tool for command line tools. So very often you have a command line tool, and yes, you could bring up help and you could try other kinds of things for the tool itself. But when you have a huge list of them, very often you want to know like very specific cheat sheet, like how, I want to execute this one-liner and work through it. And as I learned about Navi, I found Navi's written in Rust. And I was like, well, there's got to be some other tool that's like kind of like a pure Python. And at the very end of the Navi, list there on GitHub, it had 9 other listed projects and tools. And there's this 100% Python project, pure Python thing called EG, just the 2 letters. And that one provides examples of common uses of command line tools. And so their little subtitle is "Man pages are great. How do you find work again? Man space find will tell you, but you'll have to pour through all the flags and options just to figure out basic usage. What about using tar? Even with the man pages, tar is famously inscrutable without Googling for examples. And so the idea is it kind of gives you built-in support for these common command line tools that you might find yourself kind of stumped and can't quite remember exactly the weird format, because they're all kind of unique, right? So things like touch, cat, brew, curl, date, diff, find, grep, all these other ones that are in there that are common things that people would do from the command line. And I just thought these are kind of neat tools. I wasn't familiar with them, that there are this ideas of like cheat sheets for command line tools, or that could be used in this case, the one for Arsenal, as a tool to make sure that you're following a common set of commands to kind of do this, I guess, fairly common job in penetration testing. If that's your role, then you would attack things in kind of a similar way potentially and simplify the use of these hard to remember commands. Do you have a hard time remembering commands? Or do you just end up looking them up?
I have a text file for certain kinds of things that are it started as a text file and it turned into a directory filled with text files. And
yeah, sure.
Some of them are just straight out, this is how you run this snippet on the command line. And some of them are like multi-process type things. So it's like, okay, I know I've done this before. How do I do? Oh, and just a little step by step, usually only 4 or 5 things. But yeah, at risk of making the age joke, I think the third time in this episode, it gets worse as I get older. So the other thing I found interesting about this was they've built it on top of tmux. Yet another way of doing a multi-paned window thing rather than, say, rich or schematics or some of the ones we've talked about before. So even if you just want to look at another way of doing a TUI, the code is interesting here.
Yeah, that's mainly why I wanted to find one that was 100% Python so that people could kind of see, command line tools are always kind of interesting projects for people to kind of build. And I could kind of see how it's structured by diving into it if it's, a pure Python thing, which is cool. Get more ideas for those kinds of things. And then also ways that you can kind of add additional pages there to help you go, or cheat sheets or whatever you want to call them. Well, that brings us to the end. Thanks for bringing all those articles and topics for us to discuss again, Christopher.
Yep. Talk to you soon.
All right. Don't forget, you can get simple cloud data connectivity to SaaS, big data, and NoSQL from Pandas, SQL Alchemy, Dash, and Petal. Learn more at CData.com. I want to thank Christopher Trudeau for coming on the show this week. And I want to thank you for listening to the Real Python podcast. Make sure that you click that follow button in your podcast player. And if you see a subscribe button somewhere, remember that the Real Python podcast is free. If you like the show, please leave us a review. You can find show notes with links to all the topics we spoke about inside your podcast player or at realpython.com/podcast. And while you're there, you can leave us a question or a topic idea. I've been your host, Christopher Bailey. I look forward to talking to you soon.